This is Jeff Badge of the Grinding Dock, and this is another part of my series on the academic papers of Stephen Malkin, world grinding guru, and the guy who I think might be the greatest academic grinder, scientific grinder that we've ever had. Okay. In part one, I talk about the reasons why I think he's the best. I talk about his approach to papers, his taking everything down to first principles, which is what you should do. So this one, I'm just going to jump right into his paper on CBN grinding. And so now Malkin is in Israel. He was at MIT where he finished. Then he went to the University of Texas at Austin. And when he wrote this paper, he was in Haifa. And this was in 1984. All right. And this is grinding of steels with CBN. Now, CBN was nothing new by 1984. We'd had CBN since the 50s, so we're now 30 years in. But I would say we didn't have an understanding of what was going on with CBN at that time. And Malkin did some CBN tests, and he did it based on first principles. Okay. And a big part of CBN is dressing. He knew that, so he dressed it different ways, looked at the dressing. And let's see now, this one's a little old school style, and it has the text and then all the pictures. And so Malkin gave all his data, as you should. He was an excellent writer, so he specifically describes his experimental setup. If you wanted to repeat his test, you probably could and do a pretty accurate job in doing exactly what he did. He's pulling into his cutting and sliding components, which he developed in his Ph.D. And then he gets into the fundamentals of CBN. And this, if you've taken my course, you have seen this picture. I pull from Malkin. I credit Malkin because this is a fabulous picture that describes exactly what happens with the forces, the tangential force and the cutting force. Or if you prefer to think of it, you can think of it as heat generation. That's fine too. But what goes on with Malkin is the tangential force and the cutting force start extremely high, ridiculously high, and then they come down as the wheel opens up. And then Malkin explored why. He said, okay, are the grits, what's happening with the grits? Are they dull? What's happening with the cutting point density? And he was very thorough. He did it at different material removal rates here. And then he measured the surface finish because as the wheel gets sharper, less dull, we expect the surface finish to get rougher, which it does. Talks about the kind of quasi-steady state value here. And it seems obvious now, but we didn't know that at the time. And it is something we needed to know. He quantifies it, and he quantified it as he should. He did it as V prime millimeters cubed per millimeter. You could even argue you should do it as V double prime millimeters cubed per millimeter wheel width per millimeter wheel circumference. But Malkin gives the wheel diameter in the beginning, so we could do that calculation if we wanted to. And we'd see, okay, how long does it take to open up, to get the wheel to open up? And so we have the wheel opening up, and this is something I talk about in my course about how the wheel starts off dull and becomes sharp. How do you cope with that? Do you grind more aggressively? Do you grind less aggressively and wait it out? Slow down the wheel speed, increase the feed rates. What do you do to deal with that? Okay, sticking your wheel's not going to do it. It's not going to pull it off. Then Malkin was very clever. He grounds and got this little curve here. He kind of filled in these here. I think this is a little suspect. It's not very often I'll disagree with Malkin, but I'm not really sure we're getting that curve there. But we're definitely getting the beginning. And then he did it, add different material removal rates to show, okay, if you grind more aggressively, then your wheel breaks in quicker. And then you have to dress sooner. Very good stuff. And then he did it for the 3 different cycles. So we repeated these. Design of experiments was very good, because he did the same experiment in a sense, but 3 different ways at 3 different states of the wheel as it sharpened. And then he took some electron microscope photos. These are not very good, of the what it looks like, what those flat dull grits looked like in the CBN before they opened up, and then how they did open up. And let's see what else. Measure the normal force and tangential force. We could pull from what that ratio is. And let's see if there's anything else I really want to add to this. his different cycles. He likes to use intercepts a lot. Sometimes they work great, sometimes they work just okay. He took pictures worth 1,000 words, to see how those CBN grits are opening up as we continue to grind. He looked at different material removal rates at the RA and how that's varying with the tangential force, etc., etc. Okay. So, excellent paper from Malkin. I use it in the book. You'll see in the book of grinding when I talk about the fundamentals of CBN, not diamonds, not diamond on carbide, not diamond on anything, not plated CBN. That'll feature in another Malkin paper that we'll talk about. But bonded CBN, how the CBN grit opens up over time. The wheel sharpens, surface finish gets worse. And then I have some case studies in my book where I talk about how the wheel opened up too quickly, or it opened up and then the surface finish got bad because they were using too big a grit size, and then how they dressed the wheel dull in order to cope with that. And I probably couldn't have been as confident or reached my conclusion, and this was actually at a company, not in a lab, but this was a bearing company, if I just didn't have an understanding of this fundamental curve and how that happens and how you get the quasi steady state value, but even though the surface finish keeps getting rougher. But once I had an understanding of the fundamentals from because of Malkin, then when I was at the company, I said, okay, I see exactly what your problem is. Your wheel is opening up, your surface finish is getting out of spec, and it's because you're using too big a grit size, and therefore you're dressing the wheel dull. And it all made sense. And once you understand first principles, everything is much easier, or it's much easier to arrive at conclusions. So this is Jeff Badger, the Grinding Doc, talking about the great Malkin papers. And this is one of the great Malkin papers on grinding with bonded CBN wheels.